Okay, next example, we're going to divide complex. So we did adding, subtract, we did multiply. Now we're going to divide complex numbers. So here's division. I look at the top and I say, can I simplify the top? 7 plus 5i, no, they're not like terms. Can I simplify the bottom? No, they're not like terms. There's only one thing I can do right now. But you probably don't realize it because what is I again? I is like the square root of negative 1. So really it's kind of like this. 7 plus 5 times square root of negative 1 over, you don't have to write this down, but just think of it. You can, but make sure you think of it. 1 minus 4 times square root of negative 1. What's wrong with this picture right here? You can't have root in the denominator, right? So what do we do in this case? Well, how would we get rid of 1 minus 4 root negative 1? We'd multiply by the conjugate. There is also a conjugate with I, okay? So instead of 1 minus 4i, we want to get rid of I because I means there's a root in the denominator. So I'm going to rewrite everything. And how do you get rid of that? You can't just multiply by I, but you could multiply by 1 plus 4i. It's like this. I would multiply by 1 plus 4 root negative 1 or 4 root whatever it was. And same with up here. Okay? This is multiplied by a conjugate. So is this. So this right here is your it's called the complex conjugate because complexes are what kind of number this is, right? Complex conjugate. Know these math terms. Here we go. If we multiply the top and the bottom by the conjugate, how would we have to multiply the top? Binomial times a binomial, we FOIL, right? Binomial times a binomial, we FOIL. Let's do the bottom first. I like that. 1 times 1 is 1. Minus 4i times 1 is minus 4i. Minus 4i, 1 times positive 4i, so positive 4i. And lastly, negative 4i times a positive 4i. This is where people miss points. Negative 4i, positive 4i, negative 4i, positive 4i. Well, negative 4, positive 4 make negative 16. I times I make I squared. That should ring a bell right here. Remember, we can never have I squareds in our final answer. It's always negative 1 here, so we'll have to change that later. Let's multiply the top. 7 times 1, 7. 7 times 4i plus 28i. 5 times 1, 5i times 1, 5i. Plus 5i times positive 4i is 20i squared. Okay, once again, there's an I squared changed to negative 1. Let's do that next. Change these to negative 1. So 7, let's do these two. 28i and 5i make 33i. And then 7, we'll just add it on, plus 7. And then this becomes 20 times negative 1, which becomes minus 20. You ever understand that? 20 times negative 1 minus 20. All over, let's do this. Negative 4i and positive 4i can't, that's 0. So really we have 1 and then negative 16 and then a negative 1 right there. So that's like negative 16 times negative 1, which becomes a plus 16, which people will miss. Okay, careful. And last, let's do it all together. 7 minus 20 is negative 13 plus 33i all over. 1 plus 16 is 17. And I'll tell you, this isn't the answer. This isn't A, because it says this. Standard form has to be A plus BI. Technically, that's not A plus. You would think, oh, that's A plus BI. But it's all divided by 17. So here's the deal. If there's a fraction, here's what you do. You split it up. You take this divided by this. 13, negative 13 over 17 plus 33i over 17, which makes the same as 33 over 17, and I like to put the I right here. Okay, it's still the same thing. I on top, I here. That looks like A plus BI. Alright, so A is negative 13 seventeenths, B is 33 seventeenths, and then there's I right here. So there you go. There's your final answer. This is tricky for people to do because they forget to break this down into A plus BI form anytime you see standard form. So star this problem. It's one of the most missed problems in the section.